First, abstract class theory part completed already. Let's do some programs. So I want to create abstract class. How can you create abstract class? Check this checkbox and give your class name. So then that is going to be an abstract class. So abstract demo, and you can take the main method if you want and do it. See, this is the abstract class. Okay, so you declare in the abstract class inside, you can declare a lot of methods. How many methods you want, you can declare. So what are all methods you want, you can create and you can. So let me declare some variables, okay? So I declared one variable. Public static final. Val equal to 100L. So like this, you can declare any kind of variables. Non-static variables, static variables, and any of them you can declare. Okay, and even static variable also you can declare, and you can declare a constructor also here, public. But you cannot create object, okay? Remember that. So object is not allowed to create, but you can create a constructor. So if not here, you can create a no for a child class object, not for this class. And abstract class demo, default constructor. And so I'm going to declare abstract methods. So how you can declare abstract? So void
method name,
any method name. So I'm just giving a run method.
semicolon.
So abstract. So I'll put a return type method, string, send message, string str. So this is the one, and the two abstract methods I create, and I create a non-static and static methods, both concrete methods I'm going to create. That means defined methods. So these are undefined methods. See, no definition for these methods. But I'm going to create a concrete methods. Please understand, concrete methods means what? Okay, concrete methods are defined methods. And these abstract methods are what we call them? Undefined.
Undefined methods.
You're not defining them. That's so don't confuse. So what is undefined means you are not giving a definition. What this method has to do, you're not giving. But here, you're defining each method, what this method has to do. Protected, static. So void, I'm just going to print small a to small z using for loop. So I think, so any other program if you want to write, if you want me to write, let me know, I'll write here. So because this we haven't written with the for loop, I'm just printing char c equal to small a, c less than or equal to z, and c plus plus. C. And that's it. And one non-static method also I'll create. So public void. If you want ASCII codes, you can print the ASCII codes of that. Print ASCII codes. Okay. Using for loop. Started, and I can bring the cursor to next line. Int I equal to A, I less than or equal to Z I plus plus. Right. Okay, so that is the, so you have a definition for this method, you have a definition for this method. This is called defined. A method, what it has to do. So this is the method structure, but I'm defining this method, what it has to do. But here, declared, but no definition. Declared, no definition, what it has to do. So you can go and you can define wherever you want, which class you want, which child class of this one you want. So this is the parent, and this you extend to the child classes and implement these methods how you want it. So let's go and create a class. So one child class, implement abstraction. Abstract. Implement abstract. Take the main method. See here, I want to show you. So why you took the main method, sir? You can ask. See, I can call this static and final variables. Okay, see, I can call static and final variables. Static final variable. So what is a static final variable? Well, directly I can call. I can call the static method. Print
A to Z.
alphabets. But I cannot create object for this class. So I cannot create object for this class. So ADOBJ equal to new ADOBJ. If I do this, it won't accept. See that? Cannot instantiate the
Type abstract demo.
abstract demo. Because abstract classes cannot be instantiated. You cannot instantiate them. Okay.
Yes.
And so that's the reason we should not create object for these things. Abstract class. That's it. You can get it. Let's go implement the abstract class. And how you need to implement? Extend the abstract class.
Demo.
Abstract
Demo.
demo. So you can get a class name directly. and see what is the error you are getting. Must implement the inherited abstract method,
Method.
abstract demo dot send, and so add all unimplemented methods. See, unimplemented methods. It's very clear and understand that, and it's very easy for you. See that. So the method's structure is added here. This method structure, see the body has come now. You see body is throwing now. There is a body. So that's how we can okay, so you can do that on the program. And you can see str. So you can build whatever the way you want. It's all in your hand. So how you want to write the logic. You are the developer. You can build how you want this method, what this method has to do. You design, right? So that's it. And call those methods. So how to call them. And the left-hand side, the parent class type. So what is the parent class here? This one.
Abstract demo.
So ABS OBJ equal to new.
Child.
Implement abstract.
So implement abstract.
Abstract.
So this is called inheritance process. See here in the abstraction process also, you are getting the inheritance, right? This is the inheritance, right?
Yeah.
And also you are overriding the methods. That means which kind of OOPS concept is this? Overriding. Huh?
Polymorphism.
Polymorph.
So what kind of OOPS concept is polymorphism? But what type of
Polymorph.
polymorphism?
Runtime polymorph.
Runtime polymorphism. So this is another example. You are calling which class you implemented, that class object you are creating on the right hand side. So that is pointing to this reference variable. So now with that reference variable, you call all the non-static methods. Even other class, parent class properties also you can call. See, I have so ABS OBJ dot send message. So you give like that. See. Okay. And that's all. And you can call even other methods also directly. ABS OBJ dot print ASCII codes. So you can call the variable also, non-static variables. It's taking error, but fine. So whatever it is. Non-static variable data is ABS OBJ dot data. See that. This is how you can call all the even child class and parent class methods. Both you can call with this concept. So that's all about abstract class. Okay. So let's move on to the next interface concept. So any questions before moving on to the interface?
In the child class, we can add our own methods also, not instead of.
Yeah.
Yeah, both
Add.
inherited and we can add own methods.
Yes. Okay. So next one is second abstraction process, the interface. So what is an interface? Interface is another OOPS concept. You can achieve 100% abstraction with interface. With abstract class, you can achieve only partial abstraction because you are showing the code, right? And half of them abstract methods, if you make, that will be hidden, the logic. So you will develop in some other classes, not in the same class. Here, you can make all of them abstract methods in the interface. Or you can declare only constants 100%. So that is the interface means. So in the interface, it's a similar to class. And so interface is going to have constants, abstract methods, default and static methods. So what are all you can write inside the interface? Constants.
Default methods, static methods.
Default and static methods and abstract methods. So in the Java 9, they allow to add private methods also. So private methods also you can add. And the main thing here is interface also you cannot instantiate like abstract class. Interface also cannot be instantiated same as abstract class. And so interface is created with interface keyword. So basically class you are creating with the class keyword, right? But interface is created with interface keyword. And even you can achieve complete abstraction. That's advantage of interface. And another thing is you can achieve multiple inheritance with interface concept. Multiple inheritance is not achievable with the class, right? But with interface, you can achieve multiple inheritance. That means one interface can extend to multiple interfaces. That is possible in the interface case. How to declare an interface? You will use the interface keyword. Like how to declare a class using class keyword, right? How to declare interface using interface keyword you can declare. So the interface body can contain abstract methods, default methods, and static methods along with the constants also. So it can contain constants also. So what is the difference between normal variables and constants?
Normal variable, we can change the value.
Okay, good. And so abstract constants, we cannot change the value.
We cannot change the value.
And series, basically an abstract method within an interface is followed by a semicolon, but no braces. That we know already. Abstract method means that's a, so how we will declare. default methods are defined with the default modifier. So you will write a default keyword you will write. But the default access modifier is different. This is different. This is you are writing a keyword, this default keyword. So in the starting position, default, and the static methods with you. So implicitly public. So these are basically both the default and the static methods are by default they are public. So you even if you omit the public modifier also, they will be by default public only. Even if you don't write public, it's okay, but still it will be a default one, a public one by default. So every method in the interface by default public. So public methods only will be there. You cannot reduce the scope. You cannot reduce the scope in the interface. And default methods enable you to add a new functionality to the interface of your libraries or ensure binary compatibility with to the code, whatever you are writing with the different interfaces. So along with that, you can define static methods also. So you know, right, as static methods, how to declare it. Method that is associated with the class, that is called static method. So the static methods belongs to or associated with a class, not with object. But so what is the advantage of making them static methods? The advantage is easier for to organize helper methods in the libraries. So you can keep static methods specific to an interface in the same interface rather than in a separate class. So you can keep them, so static methods in the same class if you want. So, and then after declaring this interface inside these methods, then you need to implement the interface. So with all the methods, say a class that implements an interface must implement all the methods declared in the interface. All the methods declared in the interface. So for example, if you are using an interface, so you expect that unrelated classes would implement your interface. For example, the interface comparable and clonable are implemented by many unrelated classes. So such kind of things, if you want, you can do. You want to specify the behavior of particular data type, but not concerned about the implements its behavior. So you can use interface concept. And also you want to take advantage of multiple inheritance of type, then you can use interface concept. So example of a class in the JDK that implements several interfaces like the hash map, so which implements the interfaces serializable, clonable, and map. Okay, so that is the overview of interface. This is a very important topic. Please read this. And the syntax of interface is access modifier, interface name, curly bracket. So integer what's equal to 200. So abstract methods, default method, default void method name. See the default methods how I'm creating. So default method starts with a default keyword. So default void method name. Static methods, static void method name. So this is the interface, interface methods. And naming conventions. So of an interface is same as a class name. So how you will give the class names? Same way you have to give here interface also. And so see this example. First the declaration you see. class, class name, implements, interface name. That means this interface must you first you declare like this. Then you can do this line. What you are doing in this line? This
Implementing
interface methods you are implementing in the
this
class. So only class can implement the interface. Any class, even abstract class also can implement. Abstract class also can implement that. It can do that. Because you can write the methods there also, right? Some methods you can define, right? That's why you can implement that. Okay. Okay. So example here is a real-time example. Public class Firefox driver implements WebDriver. You can implement all the WebDriver interface methods in this class. So how can you map interface and implementing classes? Okay, you declared an interface. So you are implementing in the classes. Then how can you call them? This is the very important first line in our automation is this is the line. First line you will write. So WebDriver is an interface. So here first you have to write interface name, then reference object equal to new implementing class. That means this interface is implemented in which class? So that class you create object. This is the object right hand side. This is pointing to this data type variable, that is this one. And how can you call the methods of this class? So this reference variable dot method name. If it is a void method. If it is a return type method, return type variable equal to object reference dot non-static methods. What is marker or tagged interface means? This is a very important. Please understand here. I'm showing practically also all this, but practice more. So in this area, you have to practice more. So very, very important concept. So access modifier, interface name, we created all. And this why I'm saying a marker interface like this? No, an interface which has no member is known as a marker or a tagged interface. So that is the marker or tagged interface. What is functional interface? So it has only one abstract method and any number of default method. Read again. So what is this? What is functional interface? What is a normal interface? What is the difference between normal interface and functional interface?
Functional interface has only one abstract method.
Yeah. Any other default methods you can have in the functional interface, but in the normal interface,
You can have as many as abstract methods.
yes, that's a main difference. So if you annotated an interface with a functional interface, that is a functional interface only. That means you are forcefully telling this interface, okay, only one abstract method only allowed, not more than one. So that is the how you can find it out. Okay.
Sir, where do we use marker interface?
Marker interface is all the marker interfaces are which doesn't have any serializable, clonable. These are all marker interfaces. But basically I am also I'm not sure of this because I haven't used anywhere this one. But I see we are having a clonable and serializable. So these are the some of the marker interfaces. If you just see marker interface example in Java. See, serializable, clonable, and remote. So these are the marker interface. But I never used this. Okay, functional interfaces we are using, but this one, but people are implementing these things automatically. You are writing so class implements these also you are writing. I've seen in the map concept here. So in the map explanation time, they will call this clonable, serializable classes or interfaces also.
So mostly we'll, like, we don't define those, but we'll implement those. Okay.
Nothing to implement. I don't understand that why we need also. But so generally, I'm not getting the real use case where exactly you need to, right, going to use. But fine, okay.
Okay.
We won't use much that one. Just for our very important thing is this part. By heart this part, these 3 lines. So when you can create, when you can do this, Nikita, when you can use this, after which steps you can write like this. So this step will come after what? After what stage? Devi? No idea. Gayatri?
After creating a class.
Shravani?
First it
To call the methods,
All the methods are. When you will write these steps, madam, when you will write these steps, huh? Oh, forget about this. So when you will write this step, so what is the preconditions to write this step? Lavanya?
When we implement the interface in the child class, then to access the interface methods.
Access the interface in methods.
No, access interface methods or
Interface methods. Where?
then
child class.
we write this in the child class.
Lavanya is almost close, but so not your thing still confusing. If you want to use this step, first you have to declare an interface. Then implement that interface in this class. So I have shown you here clearly, right? This interface must be implemented in these classes.
Yeah.
Any class line. Without this part, you cannot do this line. So precondition for this line is there must be an interface already, and that interface must be implemented in one of the classes. Are we good? So this is part is I'm more interested, but you're not asking any doubts. When you can use this one is very important. These 3 lines stick to your walls. These 3 lines. Okay, fine then. So that's a functional interface. and normal interface difference. So these are the examples. I'll show you that before going for examples. So what is the relation between class and interface? So between class and class, what is the keyword you're going to use?
Extends.
Extend.
Extends keyword. Class and interface between?
Class
Implement.
implements interface.
Implements
Interface.
interface. So interface and so another interface
Extends.
extends keyword.
Interface extends other interface.
Yeah. So that is the relationship between class and interface. Then we have a hierarchical inheritance, this one. So one interface extends to another interface and another interface. So you are just extending that. And so see here, one interface extends to this child and another child also. And this is the multiple inheritance. A class extends to, implements the interface. So interface is implemented in the class. So that's the implementation part. Any questions here before moving on to the difference between abstract class and interface? Okay. So give the definition first, abstract class definition, then move on to the interface concept. First step is abstract class can have abstract, non-abstract methods. So interface can have only abstract methods. Okay, so second point. Abstract class doesn't support multiple inheritance. Interface supports multiple inheritance. So abstract class can have final, non-final, static and non-static variables. And so interface has only static final variables. Static final variables. You have only constants, that's it, inside the inside where? Interface inside. So abstract class can provide the implementation of interface. Interface cannot provide the implementation of abstract class. And abstract class can provide the implementation of an interface. Interface cannot provide the implementation of abstract class. So the abstract keyword is used to declare an so abstract class. Interface keyword is used to create the interface. So abstract class you need to extend to other classes, and interface can extend to any other interface only, not for any class. So interface basically an abstract class can be extended using extends keyword, and interface can be implemented in the class using implements keyword. So Java abstract class can have access numbers like private, protected. And that's all about the interface concept. So any questions before going to the program? Okay, no questions. I'm taking as no questions. Let's move on to the interface. So I'm going to create an interface and then you can call. So next I want to create an interface, right? This is the interface. So here you can give to any shape interface I am creating. So what are the different shapes? Okay. So let's declare some interface methods. First, we have to declare an interface variable, constant, right? The constant. Now, what is going to happen here is before constants, automatically it will add public final. So next, so we have to declare abstract methods. I'm going to declare abstract to void draw method. Abstract. I can see a double get perimeter. Next. Okay, so what is the mistake here? Can anyone tell me?
Return type, sir. We should write return type.
So something wrong here. So anybody can catch?
We have to write return type, sir. That's
Oh,
why it's
sorry.
showing it.
We cannot write the method logic.
Yeah, sir. We cannot write method names.
This is wrong.
Yeah,
So you
it
should
is
not write a
undefined
body.
method.
These
Undefined
are
method.
all undefined methods. Okay, you cannot
Yes.
write the method body. And also you don't need abstract keyword also to write here. So by default, public abstract will add to all the methods. See that? Like this. You can create the methods. And also I'll create, see internally what it will do. It will create public
Public abstract.
abstract double
Get
get area. Like this. So what is the keywords adding for the abstract methods?
Public.
default.
Default. Where is default, madam?
Public we are using. Public.
Yeah, public. Sir.
Only public. Any other keywords?
If it's not abstract, it will add abstract and final for the variables.
So abstract to final belongs to which category?
Non-access modifiers.
Non-access model. It's excellent. Super. So Lavan is up to date. Good, very good. I'm so happy. At least one person for all my effort, she is giving the really happy. But others are, I don't know why others are not reading. And you have to take inspiration from them. Why I cannot read? Why only Lavanya? So So if you want Java, you should read it. This is very simple logic. Okay. Next, abstract methods are done. So I'm going to create a default methods. So default methods, you should start with the default keyword. It should start with a default keyword. So default to void, and I'm going to create a run method. This is the one. I'm just writing simple, okay? So not much. So creating a static method. See, I'm not writing public keyword also, but automatically public keyword will add here. This is the defined methods. You are defining the methods here. Static int get cube index. So return. That's it. Okay, so that's all the methods I have created in the interface inside. Now I need to implement this interface. I see I have a constant. I have abstract methods, default methods, static methods. Right? So this is what we declared, right? And we discussed also. How I am creating interface?
Using interface.
Using interface keyword. So that's the interface. Let's implement this. So what are the different shapes?
Rectangle, circle,
Mhm.
Circle, square.
parallel.
Right? So these are the ones. So let's implement the circle. So that means shape methods I'm implementing in the
Interface.
circle class. Not interface. I'm not creating interface.
Oh, yeah.
Interface inside you cannot implement.
Right, external.
So you cannot implement in the interface inside. Please remember that point. No implementation at all. Interface inside you can just declare the abstract methods. That's it. No implementation. Only class can implement the interface. Only class can implement the interface. Finish it. If you want, you can take the main method, otherwise remove it. I'm just going to implement. First implement only, I will do that. So what is the keyword we need to use?
Implements.
Implements. So which one you are implementing?
Shape.
Shape.
So shape is a what kind of type? Interface or class?
Interface.
It's an interface.
Interface. So that means implements keyword will come only in case of interface. So this the right hand side is the interface and left side is a class. So now implement or add unimplemented methods. You add them. So draw method, get area method. But see, if you want to draw the circle, if you want to get the area of the circle, if you want to get the perimeter of the circle, what we need?
Radius or
Radius, right? So you're right, absolutely right. Radius you need. So how you can declare a radius? So I'm just declaring a radius, right? So how you can assign the value for this? What kind of variable is this? So what kind of variable is this? What kind of variable is that?
Non-static variable.
Non-static variable, right? Non-static variable. How you can assign the value for this instance variables? What is the procedure? How can you set that instance variable values? Hmm? How can you set that instance variable values? And I already told. Then what you learned, Nikita? You told you understand the encapsulation. What do you understand, madam?
setters.
By setters and getters.
I don't want to use setters and getters. What is the other way? Hmm?
Data.
What is this?
Oh, constructor.
So I told, right, constructor is the one you need to use for assigning the values. Instead of setter methods, you can use parameterized constructor to set the instance variable value. So what is this, Sandy? You're not reading at all. That's it. That's how to set. And I have shown you in the constructor. I have shown you. I have shown you in the inheritance. I'm showing again in the even polymorphism also. I have shown you. Even I am showing now in the abstraction also. Everywhere 4 times or 5 times I have shown you this, and still you're not able to answer. Means what is this? This concept is a very important concept. I given one example also to do the mobile class, right? You can do with the constructor also that instead of setters and getters. Okay, fine. Okay, so what is the area? How can you get the circle area? What is the formula?
Pi r square.
Pi r square.
Pi r square. How can you get the pi value?
3.1.
18, it's constant.
So I don't want to know hard code. So there is a procedure. So there is a constant declared already in the one of the class. We already familiar with that class. I
Math.
asked her to
Math.
explore.
Math.
Exactly. Excellent.
Math
Yeah,
class.
math class. So math class, that pi value is defined already. So they already defined that constant. Get area. So I'm writing pi r square, right? So math dot pi R square. Hmm?
Radius.
That's it. So how can you get the perimeter of a circle?
2 pi r. 2 pi r.
Pi r. 2 pi r. Excellent. That's it. So about this circle class, how we can do that. Okay. Any questions? Same you can implement for the circle, square, rectangle, and please complete that task and come back tomorrow. Okay. So what are the classes you need to implement?
Square, rectangle,
Square, rectangle, triangle also. So 3 classes you implement, and so you send me that. I'll monitor each and every person in the class. Everybody must finish this. So yeah, they have to create an interface, and they should create a circle class first and implement them. And then you have to create one more class and implement the same shape interface, and one more class, circle, square, rectangle, triangle, implement and come back. So is it clear on your tasks what you need to do? I'll check each and every person. So please finish the task and